This is Rajat Kumar Shukla from Perpetual Learning. Today I will show you application of LTSPICE software to power electronics. So what are the application? What are the advantage of LTSPICE software to the power electronics? So before discussing on this property of the LTSPICE software, before go through this lecture, I want to tell you that what is a procedure to install the LTSPICE on your system. Suppose your system may be Windows, maybe Mac. So it depends. I mean, whatever processor you are using, whatever operating system you are using. So based on that, LTSPICE is available in the internet. So here, this is the slides LTSPICE installation guide, which is giving from PL Innovation from the Perpetual Learning. So this is the one by one installation guide, which is available in the internet, or you can download this guide book from our website, or from the comment box of this YouTube channel. So if you are unable to catch this installation guide, you can just write it as on this register@perpetuallearning.in, or you can visit from www.perpetuallearning.in. So this installation guide will provide you one by one step how to install this software, what is the procedure. So I will not discuss more about this installation. So I'm just directly going I'm just going directly with the LTSPICE software because I have already installed it. So I'm just moving ahead because course is too long, so I have to discuss most of things. So I'm not going very small steps. I'm just going one by one, but very basic things. This is the front page of the LTSPICE software. Okay, so you have to create new piece. This is a new schematic. If you follow my cursor, this is my cursor, and this cursor where I am, this is a new schematic. If you just click on it, then new page will be open, and here you can draw your circuit. Okay, so now the scene is this page is not only opened by this new schematic. You can use your shortcut like control plus n. You can write it, and a new schematic page will be open. So today I will show you the ideal switch, how we can generate in the LTSPICE software, because most of student will think like LTSPICE can only provide you a realistic spice data. I mean, manufacturer will provide you, and you have to add that library in your LTSPICE library file. So there is not necessary. If you want to work with the ideal switch, then how you will provide you, I mean, see. So before going to that, here this is the third toolbar, and in this toolbar, that this is, remember, if you follow my cursor, this is the component. Okay, if you click on it, the library will open. Whatever you need it, you have to write it here. Suppose I need a diode, diode, so I can write it here, diode. So this diode will come, and just click on it, and if you just right click on it, then it will be automatically disappear. Okay, I mean, the second otherwise you can use here diode symbol is also. If you follow my cursor again, then here diode is also available. Then just click on it, and you can use it, and again it is coming, so you have to stop it. Yeah, you have to disappear this. So you have to right click on it, then it will be again disappear. Okay, so this will be come here in this way. Suppose you want to delete it, so you can use it from this. If you follow my cursor again, then this cut, I mean, this toolbar, in this toolbar there is a cut. It is in format of some cut format. You can use it, this tool. Otherwise, in your keyboard, if you press the delete, then this will appear in this way, and you have to just click on it, whatever you want to click. So now suppose this already appear here, and you want to just rotate it. Okay, so firstly you have to select this drag option. Now just drag it and right click on it and select it and press Ctrl plus R. Now this is in my desired position and it will come into this action. Now select the register. Here where I have selected register, you can use this component button and you can write it, or you can select it from the directly from this toolbar. Okay, so I have just selected directly from this toolbar. It will come from from default. Whenever you just install it, then it will come here. Now to select the DC voltage sources, you have to again go to the component option and write the voltage. Remember the keywords, because here keywords is very important to search your desired component. So write it voltage. Okay, now okay, here just click here and disappear. Right click on it. Now to connect the wire, follow my cursor, and here in this toolbar, here the appearing wire, here the tool is appearing as a wire. Connect it, and this is a node. Just click on it, connect the external node. Again the same procedure you have to follow for to connect the all nodes. Okay, now select the resistor. You have to be click on it, whatever you want. Suppose I am choosing 100 ohm. Now go to your go to your cursor, and whenever you bring your cursor on this component, this cursor will appear as a hand. It is showing like in the window. Just right click on it and put the right click button. Suppose you want a AC supply, because I want to make this half bridge circuit a simple half bridge circuit, so I will go with this advanced button and just click on it and go to the sine wave. Here you can see that pulse wave, you can just generate it, exponential shape you can generate it, or you can use the external datasheet file. So I'm just using here sine wave. So for sine wave, so here DC offset will be 0. Amplitude I'm choosing of the sine wave is suppose let's say 10 voltage. Suppose the frequency is 50 hertz. Delay time I am choosing 0. Theta is I am choosing 0. Phase relay is choosing 0, and n cycle I'm leaving is as a empty, because by default n cycle here, if you leave as empty, that it means LTSPICE consider it as an infinite number of cycle. If you just put here 2 number of cycle, 3 number of cycle, then this sine wave generate for that cycle only. Now you have created your circuit. Now you need to give a maximum time, some kind of solver. You need some kind of solver to solve the processor, to give the instruction to processor, your system, that LTSPICE will solve in that way. Okay, so you need before going to run, you need to go with the simulate option in the second toolbar. If you go with that and go to the simulate and edit simulation command, you have to write it. This is a transient. There are different way to simulate it, so I will tell you for each and every way to, what is the use of AC analysis, what is the use of DC sweep, what is the use of noise, or different things. For the time respect solve, you want to solve for the time with respect to time, so you need a transient. You need to select the transient and select a stop time when you have to just stop it. So I'm choosing 100 millisecond. Here 100 millisecond, here m, small m is stand for milli. If you write it is a mega, capital M, small e, and G. capital M, small e, G, mega. So it will stand for the mega ohm, 10 to power 6 ohm. So here I am writing small m only. So LTSPICE is considered as a 10 to power minus 3 second. Okay. So 10 to the power minus 3 multiplied 100. So 100 millisecond I have used. So time to start saving data. So what time you require? Suppose if I select the 0, then whenever the t greater than 0 in the LTSPICE, it will take a data from the t equal to 0. If I choose a 10 millisecond or 20 millisecond, then it means it will consider whenever the time will be greater than 10 millisecond, it means then the data will store. So it will neglect the data before the 10 millisecond, 0 to 10 millisecond, it will neglect it. Maximum time step. So usually it's depend on what type of circuit you are using. So for now I would prefer that leave the empty. So LTSPICE take this maximum time step accordingly. I mean by default whatever it wants. So remember here I have not specified the diode. If you just go here, then I have not used diode here. Okay, so let's see what will happen and what is the problem with this default. Oh sorry, here you need a ground, right? So I'm using ground here. Where I have to connect it to ground, I mean how I have. So here in the third toolbar, if you follow my cursor again, then here is a ground, then I have selected it and I have just directly connected with this I mean in this bottom line. Okay, so in the face in the neutral line. So I have just run it. So here two windows appear. Actually you can zoom it, but just to show you the, just to simplify the things for now, I have compiled this two window in I have compiled this two window in one screen. So here the result window, here is the circuit window. If you select in the circuit window and you want a result, then you have to select I mean there is a probe is appearing. If you follow my cursor here, the rate probe is appearing here. Okay, and if you just left click on it and move, then you can see here the second probe is appearing, and whenever you connect the second probe here, then here is a black appearing here whenever you connect the wire. So here red with respect to black, the voltage will appear in this mode here. Okay, so suppose let's say I want to see the current, then only just go with that just go your cursor on whatever the component, I mean which component you want the current. Okay, so current I have just put here on this diode and just click on it. So this appearing here this format. So let me zoom it, and if whenever you zoomed it, so I am using suppose for the one cycle only, and here for the auto range, because here 0, this is the 0 line for the current voltage, here voltage is appearing, and this is the current of the through the diode. Okay, so I have zoomed it. So here you can easily see here is some time gap, you can easily see. Okay, I mean this 0 obviously, let me zoom it. Okay, so I mean this is the 0 line of this voltage and this is the 0 line of the current, which is not possible. That means this diode, this default diode is not accurately defined in the LTSPICE. So you have to accurately define. So suppose I'm making this diode ideal, so this diode should be in ideal case. So what should I do, what should we do to make the diode, I mean this diode should be ideal case. Okay, so what I can do here, I can go with the help. Here help button is available. Whenever you click on the help, so here help topics, go to the help topics, and yeah, so go to the index and write, remember this keyword dot capital MODEL. Whenever you just enter it, here you can see this is the model of the SPICE data. You can make every model, get it NMOS, take it PMOS, take it NGBT, NBJT, take it PBJT, IGBT, or diode. Every switch you can consider as an ideal case, or whatever non-linearity of the device you can add there. Okay, so here I'm using a diode. Here associated circuit element is shown as a diode, so I'm just click on it, diode. Okay, so here the diode manual is available. You can just read it and you can just follow it. Okay, so I already read it, so I will not show you the scenario, like I will not waste your time. So I'm just going how to put, how to put that command to this window. So what I can do here, in the third toolbar, if you follow my cursor again, then here spice at the last, at the spice directory is open, and you have to write dot. Maybe it will be not appearing here in your screen because of the small screen, so I will show you. So dot model, capital D in bracket, it is a command, okay. You have to write R on is equal to, suppose I am choosing 0.1 milli, give a space to put the R of resistance is stand 1 mega ohm. Okay, so here it will appear, it's look like that. Yeah, so yeah, in this way. So here dot model, this D, this second D, after the dot model written D, is this D is stand for this name. If you change this name, this diode 1, this name is a D. Whenever you change this name, you have to change this name. Okay, dot model is a command, D is a name, and this D, the second D, written after the written after the second word. So in this third model, capital D, after that written is a bracket, R on resistance is a 0.1 milliohm. Wherever the diode will turn on, and off resistance will be 1 mega ohm. Okay, so now it is in ideal case. Okay, now run it. Whenever you run it, now let's check it is working properly or not. So here you can easily see there is 0 voltage is crossing it. This is the green line of the voltage, the 0 voltage is crossing, and the current is exactly 0 at the condition of the 0 crossing line of the voltage, which is true, right? So now you can conclude here, if you want to make a ideal diode in the LTSPICE, you need a command which is called the dot model, and you have to put this way. Now suppose I want to make a I want to check a the characteristic of the diode. Okay, I want to characterize the diode. So to go with that, you have to change this dot transient phenomena. So just go this dot transient phenomenon, with your cursor, and this cursor appear in this way here, and right click on it. Now change from dot transient to DC sweep, and in the first source, what is the use of it, I will explain in my further videos. For today only, I will show you how to make the ideal switches. So in the number of first source to see, you have to write the that source voltage. So here the voltage appearing here, the name is V1. Okay, so that component name is V1. So write as it is V1. Type of sweeping is a linear. Start sweep from which voltage? So suppose I want to track it as minus from the minus 10 voltage, and stop voltage will be 50 volt. Increment would be 1 volt, and just okay on it. Okay, and now let's check what will happen. Now run it. Oh, once again, here you have to give some label name across the this diode voltage. So to give that label name, follow my cursor, and here is appearing here label net. Just click on it, write your whatever the label name you want to give. X, suppose I want to give here, one label name is X and another label name is Y I want to give. So again I can change is Y yeah, so in this way. So again run it. So yeah, so here you can easily see here one more important point here, the current should be follow properly the what current you are taking here. So I have just click on it in the diode current. So here appearing is a diode current. Okay, so this is the current versus voltage is appearing. Okay, if it is not appearing here, then just right click on it and write v1, whatever the voltage here, v of x comma y. Let's see what will happening here, minus 10 volt and v of x y. So this is a diode voltage, this is a diode voltage, and this is the diode current. Okay, so how you have used the diode voltage here in the x-axis, you have to return v, capital V bracket में x comma y, and it is look like is this is the IV characteristic of the diode. So here at the 0 volt, that means diode has turned on, so current is going to maximum. Here in this quadrant, I mean in the negative x-axis, here the current is 0, the voltage is appearing in the cross in the high value. Now suppose you have increased your on resistance towards, suppose it is 10 ohm, then what will happen? Then this slope will be just drop here, I mean look like here, so this in this way. Okay, so 10 ohm is appearing because the resistor is considering here, right? So what is the meaning of it? What is the meaning of it? Because resistance, if you increase more and more and more, then slope will be decreasing more and more and more. Okay, so that is the reason slope is decreasing. So always we try here, because you are making a ideal component. However, you can say that this is not exactly ideal, but you are making a as an ideal component. So here I have written 0.1 milliohm. You can put the forward voltage, I mean the built-in voltage of the whatever you want. So suppose I have put it the 0.7 volt, then what will happen? Let's see. So here if I zoom it here, see here you can say 0. After the 0.7 volt it will be appearing in this way. Okay, so I don't think so in the ideal case you need a 0.7 volt or 0.3 volt, because this you are trying to make a ideal switch, so I don't think so it is required. Okay, so this is appearing in this way, in this fashion. Okay, so here, so suppose I need a, not ideal, but I need a real data of the diode. So you have to put here, so you have to firstly disable this ideal diode. Okay, so just go with that command, I mean whatever the command is here, just go with your cursor and just right click on it and put a comment here. I mean in this section you can put a, if you just click the spice directory, that means it will act as a command which LTSPICE will give to your processor. Otherwise, if you put a command, then LTSPICE consider it is a command and no need to take any action on it and on this written data. Okay, so now you have disabled this command, that means this is a default. Now you have to select the real diode, so pick new diode. If you click on the pick new diode, that there are already available some data from the LTSPICE. You have to click on it, whatever the breakdown voltage you want, whatever the average current you want. So I'm just taking a firstly data, I mean just for the action, and now I'm checking a IV characteristic of this real diode. Okay, so just go with the result data and run it. Whenever you run it, you can easily see that characteristic is following after the 0.7 volt. And let me zoom it here. This is the diode voltage and this is the diode current. So then you can easily see that the current is following, I mean in this exponential shape in this manner, and after that it will be linear. Okay, it is a following. So this is the IV characteristic of the real data. And what I have shown just before, that it was a it was a ideal and characteristic ideal data. So remember, if you want to make it a ideal, then you have to change this name, I mean this one and 914, and you have to use this command dot model d, and in this fashion. If you use a real diode, then you have to select here, pick new diode, and you have to, you can use from in this data sheet whatever you want, and spice model is available. Okay, so what we have learned today? So we have learned the first thing, that we have created the circuit, I mean the half wave rectifier circuit, which is the basic circuit with the resistor load, and we have connected the default diode with the default diode, and we have found this default diode has some drawback, so uh, we need a ideal diode, and or we need a practical diode. Okay, so in the ideal diode you need, I mean if you want to create the ideal diode, so what you will do, so the command would be, this is the dot capital M small capital O D E L, here the variable name, here the D, bracket on capital R. You can write it, for my case is I have used 0.1 milliohm, space is here, and off resistance 100 mega ohm will be here. So this is the command for that, or you can use it forward, I mean built in voltage, but I am not using here. Remember, this diode is a variable name. I mean whatever the diode link you are using here, suppose this here is a D1, and here the value of this diode is a D you have written, then this should be, and this should be proper. If you written is a ideal name, then this should be proper, and this D is a linear, I mean the ideal value. Okay, this is the command, I mean this is the value which recall to dot model that LTSPICE will do, this is a diode, and this variable name is a diode, and it should act as a in that way. Now the third thing we have learned, that the keywords is very important point. So if you go with the help, it's a dot model, and you can easily see the so many things. Okay, so but I will not write it, I mean this is in conclusion point, so I'm just going with that. You can use your practical diode, using of from pick new diode, which is inside in the diode model only. I mean this option you can use it, and you can use your whatever voltage rating and current rating required diode, that is spice model, you can use it. My fourth point, we have checked the IV characteristic of the diode, what diode we have make here, what diode we have made here, and in this IV characteristic diode you have to use, what we have to use, dot DC. I mean this is available in the in your toolbox, or I should say simulate option, where is a command button is available, and you can use it. Okay, what I have shown. If you are unable to understand my 4 point, then you can just go back with my video and you can just see it. Okay, and last but not the least, to measure the voltage, I mean how you choose the voltage. Suppose I have written this is the point X, I have written this is the point Y, using of label net. Then to measure this particular area, you have to write in your result section in this algebraic fraction vx comma y, which is nothing but v of x minus v of y. You can write it in this way also or in this way also, both are correct. Okay, so in the result window, I mean, there is available and here is a x-axis, here is a y-axis. In this x-axis you have to click here, and the small window will be open it, and in this small window you have to write it v of x comma y. Then here this window by default it is in time axis, then this time axis will be changes with this voltage axis, so you can easily see. Okay, so finally we have able to made a diode, I mean ideal diode, and we have able to make a or select a spice model of that diode. Okay, thank you.